In this lesson, we'll continue our discussion of learning target number 1. We'll talk about how to make accurate measurements and how many numbers to record in an answer when doing a calculation using the correct number of significant digits. Chemistry experiments are very similar to baking a cake. If the measurements are not properly made, your experiment won't be successful. In chemistry, we want to be both accurate when we take measurements, and we also want to be precise. There's a common misconception that these two terms mean the same thing. They, in fact, mean totally different things. Accuracy is defined as how close your measurement is to the true or the expected value. Another way of looking at it is, how correct is your measurement? Precision is how close together multiple measurements are to each other. In science, we often repeat experiments or measure things many times and take the average of what we've recorded to make more accurate measurements. Here's a diagrammatic difference between accuracy and precision. If we look at this dartboard, here I've thrown 3 darts. If my target or my goal is the bullseye, you could say that I was fairly accurate on this dartboard. But because my darts are far apart from each other, I am not precise. If you have a look at the second dartboard, it's the exact opposite. My 3 darts are nowhere close to the target bullseye. That means I'm not accurate. But if you look at how my darts are spaced, they are very close together. That means I may not be accurate, but I have precision when I'm throwing my darts. Being both accurate and precise is displayed in this third dartboard. All 3 of my darts are really close together. I have high precision, but also they are very close to the target, the bullseye. In science, we need to be both. We need to take accurate measurements, and we only want to use multiple measurements that are really close together, or precise. Whenever you take a measurement, you always have a degree of uncertainty because of the limitation of the measuring device. The more ticks or gradation the measuring tool has, the more accurate and the more numbers you can record in your measurement. If given the choice, you always want to use the most accurate measuring tool that you have available to you. For example, in the diagram below, we can measure the length of this nail with 2 different rulers. Ruler A would give us a less accurate answer because it has less gradations or ticks than ruler B. Because we have more gradations, we can write down more numbers in our measurement. But how many numbers do we actually record? When you're making a measurement, make sure you record all of the numbers you can directly read off of the instrument or measuring tool. And then you must estimate one more value. This is the convention when taking measurements in science. For example, measuring the nail using ruler B, I would read off 4 centimeters off of the scale, and my nail extends past the 2 millimeter mark. So I would write down 4.2. That's all of the numbers I can read directly off of the scale. Now I need to estimate one more value. The nail is not exactly at the 4.2 mark on the ruler. It extends a little bit further. I estimate how much more and record that number. I'm going to call it 4.26 centimeters. Now you might not agree with me. Different people might look at the same object and estimate a different final number. Set up some kind of system with your lab partner where you can agree on what the measurements are. My system in university was my lab partner was right the first time we took a measurement, and I was right the next time. When you do calculations with observations, your answers are only as good as the least accurate measuring device you used. Therefore, scientists have developed rules for rounding final answers and for how many numbers to actually include. Before we get to those rules, you need to know how to count significant digits in a number. Here are the rules. Rule number 1, all non-zero digits are significant. For example, the number 2.314 has 4 significant digits in it. Rule number 2, when numbers are expressed in scientific notation, only the digits and the coefficient are significant. For example, if I have 8.62 times 10 to the 4, only the numbers in the coefficient are significant. So 8.62, that's 3 significant digits. Rule number 3 describes zeros, and there are 3 different kinds of zeros. Zeros that are between non-zero digits are always significant. For example, 130.008. We count these zeros here because they've actually been physically measured. So 130.008 has 6 significant digits. Leading zeros we never count. They're actually just placeholders. For example, 0.001. Our number actually starts at our first non-zero digit. These zeros don't count. They're leading. So we have 1 sigdig here. Trailing zeros are also not significant unless there is a decimal in the number somewhere. For example, if we have the number 19,000, that only has 2 sigdigs. The 3 zeros after have not physically been measured. A better way to communicate this number to make it clear that it's got 2 sigdigs is to put it into scientific notation. The last example, 1.2300, has 5 sigdigs in it. The final zeros count because there's a decimal in the number. That's code for the scientists telling you that those zeros were actually physically measured using a measuring tool. Use the rules we just discussed to determine how many sigdigs are in each of the following numbers. Pause the video until you have all your answers. Check your answers over and see how you did. Here are the calculation rules that scientists use. When multiplying or dividing numbers, your answer should have the same number of sigdigs as the number in the question with the lowest sigdigs. For example, if I take 3.323 and times it by 1.7, my calculator tells me the answer should be 5.6491. That gives me too many estimated digits. In science, we only write down one estimated value. Because 1.7 only has 2 sigdigs in it, I can only report 2 sigdigs in my answer. That 7 was actually estimated because it's the last digit. So what I do is I look at my answer and I round it to include only 2 sigdigs. Now for rounding, it's just like you've done before in math class. If the next number is equal to or larger than 5, you're going to round up, and if it's less than 5, you're going to round down. So because I have a 4 here, my answer becomes 5.6. When you're adding or subtracting, the rule is different, so pay attention to what you're doing in the question mathematically. Your answer should have the same number of decimal places as the number with the lowest decimal places in the question. For example, 15.98 minus 4.9872. When I plug this in my calculator, I get 10.9928. Now that's too many digits. The question gives me 15.98, and that only has 2 decimal places. I must round my answer so that I have 2 decimal places. I get 10.99. The last two examples show you the calculator giving you more digits than necessary. It does happen that your calculator doesn't give you enough. If that happens, add zeros at the end of your answer until you get the correct number of sigdigs. Try out some calculation questions below. Pause the video until you get all of your answers. Here are the answers. Check them over and see how you did.